Hello, my name is Martin and this is 3D Printing Iceland. In this video I'm gonna show you my design of a GoPro mount for my Prusa MK3 printer. I went through the process of designing in Fusion 360 a GoPro mount from scratch. So I'm gonna show you my design and the outcome of the design. So let's have a look after the intro. For the MK3 printer there are several GoPro mounts already on Thingiverse, and instead of just grabbing one of those and print out, I decided to spend some time in Fusion 360 and design a GoPro mount from scratch without referencing any other design. I wanted to learn to use Fusion 360 more, and this was a great project to go as this as a practical print, and the outcome can be useful for both me, and I will also publish this on Thingiverse and have a link to the thing on the video description. But going through the design, there was several places that needed to fit perfectly before I could go on with the general shape of the mount. The first one was deciding on how to mount the piece to the bed frame, and decided to use one of the screws that is in the corners, because now like on the MK2 printer, the PI sheet is covering the corner screw, so you can't take them out. But on the MK3 the removable build plate allows you to take out the screws that hold the PCB to the Y-axis frame. So I decided to use one of those screws to hold the piece in place, instead of using zip ties or some other method of having the piece fixed to the Y-carriage. So that was one of the first design decisions I decided to make. And first I measured out the size of the Y-carriage end that the screw was going in, and one of the first pieces I did was a simple profile to fit around the Y-carriage, and I measured out the width and height of the carriage and found out the right tolerances for this being in a good tight fit, but not too loose. And you always have to count on different extrusion widths and diameters to get it perfect, depending on filament and printers. But I was using my Prusa MK2 and Filafarm ABS filament, and using the settings in a slicer I'm using for that filament and that printer, I dialed in the width and the height of the profile that would go around the frame. This is one of the pieces I printed out that was having the end profile of the piece, but this one cracked out a little bit because the tolerances were too tight, so I had to increase the size. Then I printed out a small item like this to see how it fitted. There are several of those items. When I was getting the hole right for the screw, there's a small metal bushing that goes around the screw, and I have several pieces where I was finding the best location for the hole. I measured out the distance from the end of the Y-carriage to the middle of the screw, but I had to account for tolerances, so I had several prints just adjusting the correct placement of the hole. And I was also experimenting with how I would print the piece without supports being inside, because if I would have to have supports inside this small hole, it would be difficult to clean them out properly. And what I did was creating a chamfer around the hole at the bottom side, but the result is that in every print I have to manually clean out a little bit of drooping, because as you can see from this print, there is a small, from inside it's a little bit messy. So just after the print you have to manually clean it out with a knife. Had this chamfer to minimize the effect of the drooping on the actual hole, and the metal bushing has a good surface, that's like 3mm surface area to sit in the plastic to be perfectly aligned, so the chamfer doesn't interfere too much with the actual piece when you have cleaned up the drooping. That was probably the most time-consuming part of getting those tolerances right around the X-carriage frame and the position of the hole and the drooping issue. When that was sorted, I went on to making the placement of the actual arm, and the reasoning for this bend in the piece is to account for the distance between the corner of the Y-carriage and C-axis motors, so they won't be too close, because I wanted the wires to be clamped around the arm, and if I would have designed this in a way that the arm would be straight out and having the wire strapped around the piece on this side, it would get too close to the C-axis motor, the left C-axis motor, so I had this movement a little bit away, and this was the first interaction of this. When I printed this piece out, I actually broke this off just to test the strength, but when I printed this out as a final piece with a GoPro mount design, after looking at specifications of a GoPro mount online, I found out that when the print head is at the leftmost position and the bed is in the innermost position, the print extruder motor would hit the lens of the GoPro Hero camera that I have. This would of course be dependent on what camera you would have, but as I was using the GoPro Hero 4 camera, I want to avoid this. So I changed the design a little bit, so this part is a little bit longer. So now the piece, the mount, so now the position of the GoPro mount is moved a little bit away from the extruder motor. So just by lengthening this part of the design, I got the position right, and that was an easy adjustment of the sketch in Fusion 360, just to extend this part, and everything moved along. And to make sure this would mount either on left or right side, I made a mirror just in the slicer, mounted this on the right side and the left side of the bed, so the design works on either position of the bed, and it's really dependent on your setup, on your lighting setup, which way you want to mount this, either on the left side or the right side. But the X-carriage is symmetrical, so everything is working correctly, and the print head or the extruder motor doesn't clash into the GoPro in either position. So this made sure that was taken care of, and the final touches of the design was in the first go. I had the mount for the nut for the GoPro fixture. I just made a simple shape for it, and it had quite a drooping on the underside, so I just changed the design a little bit, so now it's in a fillet way, reduced to a slope, so there's no drooping on the underside of the hole for the nut. So that was just a minor detail. Also a detail I added was a small hole in the corner here, and the thinking of that is, if you have the GoPro mounted and you have the power cable, the USB cable to the GoPro, and that goes down, and you can clamp it with a zip tie on this position, and then you can use another zip tie through this hole and clamp the cable down, so the cable won't be moving in the connector of the GoPro. So you don't wear out the connector in the GoPro. So you want to clamp down your cable, so you have these two positions to clamp down the cable. Then in my case, I measured out the width of the cable I'm using, and I added those small clamps, so I could just clamp down the cable inside those 4 clamps. And this, I think, is a good design for it's just a pretty standard USB cable, and it's a pretty tight fitting, but you have to just get the cable pressed in, and then you don't have to use zip ties, and I think this is working quite well. There is a little bit of drooping issue on the uppermost print, but that's easy to clean up with a knife. But here's a small fillet on the underside, this one, and the underside of those printed out quite good. So I think the final design has a pretty good overall printing option, and there's a small place that you clean up, that's here, and the hole inside where I showed you before, because it starts to print in mid-air to make the hole, so you have to clean up those two places to get the print looking good. And I just broke off end of the print, and the piece, the whole piece inside is hollow. And the reasoning for that is I printed this with 4 parameters, and to get this extra strength, and using a hole that is in a shape like that gives good strength, and you can see the layers in the print, how they build up. And this design makes the body of the piece much stronger than if it was just a normal square with normal infill. So this is a design decision I decided to do to make the part more rigid, and it's really strong. I can't break the part piece. I could only break it on the topmost part where the layer lines meet up, but this shows the inside, and you see this better in the Autodesk Fusion 360 portion of this video, where I show you the design there. So this is the look of the final piece. And I made a video with this GoPro mount where I show the initial stages of printing in a normal speed video, so you can see the viewing angle of the GoPro mounted on this mount, and also the video, so you can see how stable it is. And then there's a normal time-lapse video with a print of a torture test print that I normally do, so you can see the view angle and how stable the camera is using this mount. For now, let's have a look at the Autodesk Fusion 360 portion of this video, where I show you in detail the design. So here's the final design in Fusion 360. It's a pretty clean design. I want to show you the steps I went through. The first steps were to get the profile of the Y carriage to fit. Did some changes in those steps, and then with the hole, here you can see how the chamfer of the hole is designed. But when printing, this part starts to print mid-air, so there will always be some drooping of plastic in this portion, and that's for that reason it's important to clean that up after the print. And here's a step where I adjust the height to make it fit a little bit more, and I carry on designing. And here I'm getting to the arm itself and building up the main arm. So that was pretty standard, creating a sketch and extruding, and here I create the hole using the shell command and the fillet function to adjust the shape of the hole. If we do a cross-section analysis, you can see how I chamfer I use fillets to make the shape of the inside in this way, and this is for strength purposes that I do it like this. Then I made the decision to strengthen this part, and create a hole for the strap for cable management. Several adjustments. Then I start building up the GoPro mount using sketches, and this is the correct placement of the GoPro mount, and I had to move it a little bit to make sure it was even on the top. And then I do chamfers on the sides here, One thing that I might change is if I would increase the width of this arm to have it match the width of the GoPro mount, then I would be able to skip those chamfers, but I think the strength of the arm is good enough in this size, so I don't think it's necessary to do that change. And then I did this placeholder for the nut. I moved it a little bit, and here I made the chamfer, or no, the fillet, did that afterwards to be more easy to print. And here I create clip for the cable. I multiplied those clips in 4 locations, and I did a fillet underneath this one here, and a fillet underneath this one here. I will have a little bit of drooping when printing this, so this is the part that needs cleanup after printing. There will be a small place here that will droop, but it's a minor issue, so I didn't want to change the design of the clip just to clean out a small amount of drooping issue. Then I decided to increase the width of the pieces. Initially they were 3 millimeters, but I changed it to 6 millimeters. So that's the end design, and this can be mirrored in your slicers if you want it to be on the right side of the bed. And I don't think it matters much. It's just depending on your setup. I'm trying out having it on the left side, but previously had the GoPro mount for the MK2 on the right side. But I might try to change it over just to see how the lighting in the cabinet that I have works best. So this, I believe, is the final design. I of course might do some changes at a later stage, and then I will do a version 2 on the Thingiverse page and upload the new model. So for now I think this is good in the Fusion 360 part. So this was my video on how I designed this GoPro compatible mount on my Prusa MK3 printer. I hope you like the design and the process, and have learned maybe something in the process. And if you like this video, please give it a thumbs up, and please comment if you find any questions in your head regarding this design or this video. So for now, I thank you for watching, and I'll see you in the next one.